let's start with some rapid fire questions. I want to answer like a yes or no or option A or B to begin with, but then you can, explain it. But what I would like to do is like later on go back to the answers that you gave and try to see how whether we can cover all of those properties. So the first one's like very simple, right? Fraud proof versus validity proof.
ZK proofs.
Yeah. Cool. Do you want to explain a bit why, like, was this one of the first things that you came across when you were starting to think about ZK proofs? Did you consider fraud proofs at that point in time and then went on to ZK proofs because of the better properties, or it was always ZK proofs to begin with?
Fraud proofs did not exist in this form when we started, but there was like a similar idea around, I think, what was the protocol called for like arbitration? TrueBit, I think, like look, we're trying to solve the scaling problem. We want to scale blockchains in a way that preserve what makes them valuable, and to do this, you want to scale verifiable computation, right? And with fraud proofs, you can only scale verifiable computation if you split your chains into many different parts, like you have many chains. Because that is where like each user who cares about one specific chain will be verifying everything on this chain. But if everyone would verify everything, it would not be scaling. It would be just like, oh, okay, we have to do more work. So you have to assume that some people care about chain A and they will be verifying it. Some people care about chain B, chain C, like thousands of these chains. But the biggest problem in this scenario will be that these chains become non-interoperable. Because you have this 7 days, like longer term period of wait until you can pass a message, value of fungible tokens and NFTs between those chains, and it just like it breaks the connectivity, it breaks the composability. You cannot really do it composable way. You have to think about something like, okay, let's do a shared sequencer and let's put all of this together. But then you're back to the idea of everyone verifies everything, and that is not scaling. That is just increasing the requirements to run the full node. That removes the idea of decentralization, and that doesn't give you these properties. While with ZK proofs, with validity proofs, you can scale verifiability literally indefinitely, like without any limits. You can have infinitely scalable Ethereum. With data availability still becomes a problem, and you have to solve it with data availability layers, and like here's Avail coming into the picture. But computation, verifiability is completely, infinitely solvable with zero-knowledge proofs, and this is what's going to happen. Like this is like, zero doubt about this. Like in a year from now, where we solve all of the UX friction points that still remain, that were blocking people from deploying non-ZK rollups up till now, and we actually built the protocols for interop, where many ZK chains can talk to each other in a single click with user experience abstracted away. That's it. That's game over. We have ZK is the end game. That's
makes sense.
Obvious.
No, I think you painted the picture pretty well. I think all of my questions after this will become a bit redundant, but I will still go ahead and ask them. Like, what is more important to you, safety or liveness?
I would say that liveness is part of safety, but safety is definitely way more important. Like, would you rather be, like, get some delay in being able to withdraw money from your bank account, or like you can withdraw anytime, but you can lose them at any moment? Like the answer is obvious.
Makes sense. And probably we will come back to some of these trade-offs in that space. But cryptographic guarantees or crypto-economic guarantees?
Cryptographic guarantees. Obviously. Like that's whenever you can solve something with cryptography, with pure math, without involving game theory, you should do it this way.
But what are the edges of cryptographic guarantees if you want to like go into a bit? Like for example, like we talk about sometimes validity proofs or ZK proofs almost as magic, right? Like we see that they are easily verifiable, they are succinct, they have almost zero trust assumptions. Again, with various different types of ZK proofs, there are different trust assumptions, but they are almost always transparent and such. And what are the edges there? Like how would you like others to think about what are the borders of cryptographic security, and from there on, where does crypto economics come into the picture?
So they only magic because they do things that are seemingly impossible. But like, did airplanes seem like magic to people when they were invented? Does AI seem like magic? You know, like it just does like very impressive things. But when you dive into it, it's quite easy. Like you can break it down in bits and pieces. It's not that complex. And now where are the boundaries where you need crypto economics? I think, yeah, around liveness, that is something that we can, like where you need people to do work. Whatever you can verify purely mathematically with computation, we should use it for this. But anything related to work, and anything that is related to subjectivity, where like whatever is objectively verifiable, we can use math. But whereas like data availability is subjective. There is no way to prove to anyone outside two of us whether I withheld data or you did not receive the data, or you received it and you just like pretend you haven't received it, right? There's no way to objectively establish this truth. And in those cases, you need cryptoeconomic and some game theory around it too.
Makes sense. Now, I think that is very interesting, and probably we will get some time to take that again. I think this one will be easy. Monolithic or modular? Monolithic or modular?
Well, modular, of course.
Yeah, I think it doesn't need much explanation, so I would just go on to next one. And here is like, do you think general purpose is better or application specific is better?
I think you do general purpose primitives and then you build application specific stuff, just like you have your processor is general purpose. You have arbitrary commands, which are opcodes that you can execute, but then you have specialized programs or tools that do certain things better than others, right? And similarly here, like the underlying primitives will be, like if we talk about scaling, they will be general purpose, but then there will be application-specific rollups, and then they will be optimized with external means to serve better some purposes that they are created for, and they will be just interoperable with others with general purpose rollups. Like you can think of this analogy as like, are cities generic or application specific? Is Dubai like application specific? Is it for some created for some purpose, or like can you do different things here? And you could argue like maybe Dubai is general purpose, but maybe there is a Disneyland outside, and this is kind of like a smaller application-specific city, right? And or maybe airport, you can consider it like as a sub-part, right? Or maybe parts of Dubai serve different purpose. So like it's kind of like hybrid, but you get the idea.
Yep. No, I think it makes sense. I think we will come back to a few different stack-specific questions when we go into a bit of a ZK stack and such. But before going into that, like verifiability or efficiency performance, like if you had a trade-off to take between it being verifiable and it being efficient or performant, which one would you take?
Well, if I need verifiability, verifiability is why we have blockchains. If you just need efficiency and performance, take databases. Postgres will do a good job.
Yeah, that makes sense. But what would be the trade-offs that come because of verifiability? Like there are blockchains which are more verifiable and there are blockchains which are less verifiable, right? So would you be asking them to just use a distributed database at that point, or is it like, and what I'm trying to ask is like, is verifiability a Boolean or is verifiability a gradient?
The verifiability is the core of what makes a database a blockchain. Like it's either a database or it's a blockchain, and what makes it blockchain is the fact that you can verify operations on this database. And this database is like decentralized and resilient, right? So without verifiability, you don't get all these other ingredients like decentralization and resilience and permissionlessness and censorship resistance. Like it only comes together with like verifiability is the basis on which you build everything else. So for me, it's a cutting point of like blockchain, non-blockchain.
Makes sense. And if it is a blockchain, then sometimes we have seen that sovereignty and interoperability are at odds. Do you believe in that? Or if you have to choose one from sovereignty and interoperability, it would be any one of them?
I don't want to choose. I was I'm always looking for the magic of and instead of or, where you don't have to choose between two, like privacy or UX. You know, like would you like should you use Gmail or should you use PGP? But the answer is like neither or, right? You can use something like Signal or WhatsApp or you know, like if you consider Telegram end-to-end encrypted, that like you can create applications that are both usable and privacy preserving. Same thing here. We can, with ZK proofs, create a network of blockchains that are both sovereign and interoperable and composable, atomically interoperable. Like maybe asynchronously, but still atomically. You can initiate a transaction on one. You like UX is beautiful. You sign once on your wallet, and then transaction happens across multiple chains. It comes back to you. There's like this is happening. Like it will take like, you know, like we don't talk about this much. We're just sitting and quietly writing code, and this will happen. This is how Ethereum will scale. It will be thousands of chains, will be all interconnected, all of them sovereign and permissionless. Like this is very important. This is something you cannot do with optimistic rollups if you want them to make them interoperable. The only way to make optimistic rollups like easily interoperable is all of them submit their sovereignty and they become one shared sequencer, like one shared like mega rollup. With ZK proofs, that's not necessary. You can have several like permissionless chains that are sovereign. Anyone can deploy them without asking questions.
For example, like let's go into it a bit more because I think this is important. Like if you think about two chains being interoperable with each other when they are also sovereign, which means that they can fork off, right? And when they do fork off, what is the interoperability primitive on the other chain? Which chain should it follow? Which sovereign choice of the other chain should it take a like? And how does it decide what is the fork choice rule on the other chain?
Oh, so you're talking about sovereignty in the sense of like sovereign rollups.
Yes.
Because like to me, sovereignty means like you have full control. Like the definition of sovereignty, like there is nothing, no one above you, no king, no, you know, like you're your own sovereign. You have all the choices to make about your chain, how it operates, how like whether you like what rules you want to put there, where you keep the money, what consensus mechanism, like any of the properties, right? If that is the definition, then you can still be a rollup on Ethereum and be sovereign, right? You don't depend on Ethereum or any like topology of the network there.
Makes sense. Okay, that clears it out. Now a few of them are probably just hot words right now. Solana L2s or not? Solana L2s, do we need them or not?
I don't think Solana needs them. Like Anatoly was very vocal about not needing L2s because monolithic chains solve all problems by their own.
Do you believe that monolithic chains solve all problems?
I believe that if you're like, it's consistent with his thesis. It makes sense in the context of his thesis. So like you cannot simultaneously believe in Solana's thesis and also believe that you need L2s on Solana. Like if you need L2s on Solana, it means Solana has failed.
Makes sense. And what about Bitcoin L2s? Are they needed or not?
They will be here. I think that you like it's like I'm looking with great curiosity at BitVM and whatever optimistic rollups can be built on Bitcoin. I'm not still quite sure. Like I need to follow up whether it requires like one of n participants that are permissioned, or one of n or like one of like arbitrary many participants that are permissionless. But I really hope that one day Bitcoin will embrace the opcode to verify snarks, and then there will be just a ZK ecosystem on top of Bitcoin.
Makes sense. And then last one, shared sequencers or not?
So like as I said before, I think that shared sequencers are now being used as a patch the gap solution to optimistic rollups. Because like optimistic rollups were trying to solve the scaling problem, then they run into the interop problem. Now they have to like solve the interop problem by creating shared sequencers. Now the shared sequencers will cause another problem. It will propagate like it always does like this when you don't have an elegant solution. I think you don't really need shared sequencers with ZK proofs. Like to me, the shared sequencer is essentially a form of sharding of a single rollup. Like, think about it. It's not taking multiple rollups and combining them together with shared sequencer. It's like taking multiple rollups, pressing them together, like making them one out of them, just with multiple shards that are not directly connectable with different address spaces, and like making them one single rollup.
It's more like
you kind of like taking this one rollup and just saying, okay, we have this multiple spaces.
So it's more like a multi-threaded program than a completely separate process.
It's definitely the monolithic thing. It is a like very, very monolithic thing.
Makes sense. Now let me switch gears and get into a more subjective style of questions, right? I think a lot of us has been, following the space and looking at many different stacks which are coming in. There is ZK Stack, of course, by you guys. There is Polygon CDK. There are Starkware, Madara. There is Superchain by the OP Stack and Optimism guys. There's Arbitrum guys have Orbit. Like, if I'm an L2 and I want to build an L2, how would you kind of say which stack to choose for? Are there trade-offs that we should be aware of, or is that like just the similar offerings by different companies?
I am obviously biased because we are building the ZK stack, and so like whatever I say, you have to take it with a grain of salt, and it just like I cannot like make an unbiased, neutral recommendation. I can say why you might want to choose the ZK stack over anything else. You want to build on something that is going to be lasting. I mean, it depends. Like maybe you just want to be here for this cycle and like build something quickly and then dump, so then take whatever works for you, right? That's one strategy. And then I'll say like good luck to you, but like, this is not really what we're interested in. Like we've been building zkSync for 6 years now, and we're going to be building it for a very long time. Like we're in the very long term. We have a mission. We have like been always very consistent about the mission and the values of zkSync. We've not deviated. Like you read all of our blog posts, all of our communication from the beginning, and look at not what we said, but how we operate, like how we approach the design choices of zkSync, how we operated, like what promises we made, what promises we held. Like we are here for a very long term, and if you are in the same camp and you want to build something that will actually change the world beyond this cycle, then you want to build on something that will last. And I can promise you that ZK is the way how Ethereum will scale. And I just don't know that like you cannot add ZK on top of like existing alternative approaches. You need to start with ZK. Like you take an OP stack and patching it with ZK will probably not work. The reason is simple. Like look how long it took them to implement the fraud proofs, right? It takes time. Like they would probably need to change the core, like rewrite completely the like Bedrock, whatever, like the engine there. So until that time, all the chains that build on non-ZK technologies will not be properly interoperable. They will be connected by existing bridges where you cannot send NFTs, you cannot send arbitrary messages, and you have to pay a lot for liquid fungible tokens, and you cannot send non-liquid, like less, like long tail of tokens. So if that is okay for you, like maybe, like I mean, like it also depends on your choices of grants or whatever. But if you are building something that will last, then you want to pick a ZK solution, and then you have to choose between the existing ZK choices. And I think it's quite clear at this point that ZK Stack is the most mature, like by far the most mature ZK Stack in existence. We have done more, we have the highest recorded TPS across all rollups, ZK and Optimistic, like at close to 200 TPS. This is what actually was recorded, right? The actual testnet we're running at Matter Labs in-house now is coming closer to 1,000 TPS with the new virtual machine. We have more transactions by like orders of magnitude more transactions processed than any other ZK rollup, and we have the lowest cost. Like I mean, we and Starknet have embraced the state delta approach compared to the cold data architecture that all the other ZK rollups are following, and it makes the footprint, the costs of data availability by far the lowest. Like before AEP 4844, we were 50% cheaper than all the optimistic rollups. After AEP 4844, again, like we and Starknet were the only two rollups that implemented blobs on day one. zkSync was the first rollup to ever submit blobs to Ethereum. So we are on track to build something very mature, and we are we'll have some really exciting releases this year. We have a couple of like really big things technologically on the protocol side to release.
No, that's awesome. Like, but that also kind of, you probably touched a few of those points a bit earlier, but with all the L2s which are going to embrace ZK Stack, how is the interoperability going to look like maybe today and then after you guys release it throughout the year and beyond?
Sure. So today, or like in the very short term, multiple hyperchains, as we call them, launch in zkSync, including Kronos, like the initiative of Crypto.com, or cooperated with Crypto.com. Gravity, there is a bunch of really interesting projects, and some of them are still undisclosed, and they're coming later. They will be in a few weeks, month from now. They will be connected with hyperbridging, where you will be able to bridge natively, like in the normal bridge interface. So the UX will be still like you go to a page, you click like send money to this other hyperchain, but you don't pay extra costs. It just costs you 2 transactions on both chains, and it's trustless. The ultimate UX will be you don't have to leave your hyperchain. You have your home chain where you have your account, and from there you do just you go to any app, go to app specific, space and time, or one of the hyperchains where you can do interesting things, and you do one click, your funds are being bridged, transaction executes and goes back all within seconds, and then you have the result there.
That makes sense. I'm trying to understand like when we were designing this, right? Because you have been, of course, thinking about the ZK space for some time now, about the interoperability. You have seen the experiences that we have been having even till now. Like, how is the design process look like? Like, was it like immediately clear that this is how is going to look like in its final shape? Although we have not probably achieved it right now, but was that immediately clear, or are you guys still evolving on the design space there? I know that the ZK Credo is out, so anyone who has not read it should read it. It's pretty consistent with what he said, like with every thing that you guys release. But with the design, what are the pivotal design decisions that you have been taking, and what guides you about that?
From design decisions is something that we reverse engineer back from the ideal user experience. And if any of you guys have tried zkSync Lite with Gitcoin, for example, Gitcoin grant programs, that was the approach that we followed from very early days. Like, you imagine like what should be the user experience. Like for Gitcoin grants, it was like you do one click and then you fund 50 projects. And back then we could only do simple payments, but we sat together with Gitcoin team and thought like, what's the way we can put it inside this browser deb page and like compress it, and like how do we get there? Like what we need to solve, like unconstrained from first principles. Like, let's not think, oh, like this is how it's always been done, this is how other people approach it. Like, forget all of that. Like, this is the end experience we want to get to. For the ultimate Web 3 experience, you can look at Web 2, and like we want to do better than the existing Web 2 applications. We want to do better than the existing financial services, better than neobanks. So you have you install an app, which is your wallet. You send your address to your friends, you get some funds from there. Maybe you get like stable coins, USDC, USDT, whatever, DAI, and you can just start using things with one click, and it's also safe. You should not be afraid that you do one wrong click on the wrong website, you lose all of your money, which was the case in the early days of the internet, where you can put your credit card on some wrong web page and then they steal your money, right? And then gradually this got solved. Now you're not afraid to be making purchases online. So we have to come to the same and then better user experience so that everything can move on chain from online.
That makes sense. And I think you're also talking about application specific ones and those rollups that are going to arise. Uh, if someone wants to build an application specific rollup today, should they use the ZK stack, or are there components of the ZK stack still unpublished or which you guys are building?
No, like if you're building application specific thing, you definitely should use and you want to use ZK Stack, because that's going to put you in the fastest way in this interoperable ecosystem where you connect to Era, you connect to all these hyperchains that are like user specific or wallet specific or exchange specific, and they will be able to access, like their users will be able to access your application, so you get access to all of these users.
That makes sense. So you said about, let's say, a 2000 TPS chain, which is right now an EVM compatible chain, right? And with EVM, we know that with a very, very high TPS comes the entire state load problems and so on. So if someone wants to, avoid the EVM and the restrictions that is coming out of it, because there are many things in EVM which have been done for general purpose nature, and by making things application specific, they might not be the most performant. So what would you suggest to them? Like, for example, people have been building, let's say, a rollup in a RISC-0 or an SP1 in a Cairo VM, this kind of newer ZK VMs, and there has been also talk about ZK EVMs. So what is your take on those ones? I understand the ZK implications, and I completely agree, but what about ZK specific VMs versus ZK EVM?
We will have general purpose transactions with or contracts written in Rust or WASM or like anything that compiles to RISC or WASM. I don't think that builders of applications should be concerned about that. In the early days of the internet, you might have written your web servers yourself in CGI, in C++, like you would write programs that would output HTTP. You don't do this anymore. It doesn't make sense. It would put you like way behind in competitive landscape as compared to like you just write your code in like whatever in React or Vue or and you just put it on the backend for services, and like the web server is someone is doing this for you. Similar thing is here. Like the stack, like there are a couple of teams working on stacks. They will have a lot more resources, a lot better engineers in a more cohesive way, just focus on this one problem. And they will be solving this way better than any application specifics. Like focus in your application logic and outsource all of this. Efficiency-wise, it will be Rust. You will be able to write code on Rust. But like for now, really like scaling is not the issue as of today. Like we solved scaling to a degree where like now the bottleneck is the useful applications. With 200 TPS, 1000 TPS per application specific rollup, it's more than enough. Like it's going to be a really good problem to have if you have so much volume as of today. Like you better focus on product market fit and fixing that.
No, that makes sense. I think in this vein, like I have a lot of questions, as you guys can see, but I think we are towards the end of time. I would say like, okay, so one thing is like L3s. There has been a lot of discussion whether L3s are needed, whether L3s are required. What's your take on that?
There is no difference between L2s and L3s. From like if you are in the ZK ecosystem, the exact topology of like where the proofs are settling doesn't really matter. Like the hyper bridging is the same. So like we just call all of that hyperchains. There is no difference. Just forget the idea of L3. It's unnecessary. It's like some technical complication which is already abstracted away.
Makes sense. And then because we have talked about a lot of these applications, how application specific it can be, performance, numbers, and so on. Can you talk about a few projects that you think are building great protocols in this space that everyone should take a look at? Like in general, this is a...
I don't want to comment because I don't want to sound biased, and I'm just like I've been working recently on deep things about zkSync and not as much. Like we have a really good ecosystem team And I know that there are a lot of really cool things are happening in other ecosystems, but it's not been my focus, so I don't want to disrupt.
That's fine. And then, and the ending note, like what should we expect out of the ZK Stack and the zkSync ecosystem in this year? Like you talked about, very exciting updates.
Yeah.
Can we get some sneak peeks?
Well, decentralization is one, which is very important, which is in line with the mission and what we've been doing for a long time, and we're now focused just on that. Then interoperability between hyperchains, and then the next generation of the virtual machine, and some interesting breakthroughs in performance and developer experience. Did I miss anything? I think those are and some really exciting projects coming to the ZK Stack or to this hyperchain world, which we'll announce pretty soon. Like it's very interesting.
Nice. I think we are towards the end of time. Thanks a lot, Alex, for joining us. It was a pleasure talking. Hopefully you guys enjoyed as well. Thank you.
Thank you all.